Welcome to the Vision Brick. In this video, I'll show you how to calibrate camera with OpenCV. So after calibration process is finished, you will have two different parameter sets. First one is intrinsic parameters and second one is distortion coefficients. You can see these values are specific for my camera. You cannot use these values. Like for each camera, these values will be changed. And after calibration process is finished, you can use these values for obtaining less distorted images. Let me show you a few examples. Camera distortion. You can see the difference, but for example, this image, you can see the face. And let me show you, yes, this one explains better. This is original image and this is distorted image. So using these parameter sets, you can try to obtain image that is more close to the original one, not this distorted one. And there are other applications as well. For example, this one. You can find real-world coordinates of specific objects relative to the camera. For example, you can see this is Aruco marker, and you can see the real-world coordinates here in meter. You can see x, y, and depth coordinates. Yeah, I will share another video for this Aruco markers. Now I will close this as well. Yeah, I think we can start, but before starting, you need few things. First one is camera to calibrate. I will calibrate my laptop's webcam, but you can calibrate any camera. Nothing changed, process is same. And you need one chessboard. Yeah, you can find chessboard image from internet, download it and display it with your phone or if you have tablet. I will use my brother's tablet, but nothing changed again. Let me show you. Yeah, you can see the tablet and chessboard image. Yeah, you can use any device. Yeah, you can try to use real chessboard as well, but I don't know if it's work. I didn't try it, but it will probably work. And last thing is you need one ruler. Let me show you why you need ruler. Yeah, you need to measure the one side of the square. So in my case, it is 17 millimeter approximately. Yeah, we will need this value when finding parameters. I think we can start. Yes, we can start. So I have two different codes. First one is for collecting images, to like directly collecting images without any process. You see. And second one is for these parameters. So basically, let me show you. We will save these parameters to YAML file as well for using it later. But I can start to explain first one. Yes, I already did that, by the way. I already calibrate my camera. Now I will show you all the code line by line, and you can find link to this article in comment section, and you can copy this code and calibrate your camera. So now I will start to explain first code. Okay, this one. And you need to install OpenCV and NumPy. You can do like go to the terminal, pip install OpenCV and NumPy like this. Okay, now we can start. Yeah, you can change this directory. I will save my images under Calib image directory, Calib image folder. You see, I already did that. This is number of images. You can change this value, but at least you need to have like 10 or 15. And these values are number of inner corners for rows and columns. Let me show you what I mean by inner corner. For example, for rows, oops. Yeah, let me count. Starting from this one, 1, 2, 3, 4, 5, 6, 7, 8. This was for rows. Here you see the 8, and for columns 1, 2, 3, 4, 5, 6, these values will be changed depending on your chessboard. Yeah, like this. Remember inner corners, not the number of squares or anything. Inner corners. So here we are reading frames, and we are converting frames to grayscale, because this find chessboard corners function works with grayscale image, not RGB or BGR. And if it finds corner, it will draw corners like this. You see the corners. For example, you can see this is a Boolean variable, and if corner is found, and if user press space, it will save image without anything on it, like direct the original image, like this. And when number of saved images is equal to this number image variable, it will close the program. So in the end, like you will have 15 images, like this. Yeah, the first part is for only saving the image. Okay, now second part is for calibration. I will explain each step in this notebook, but now I want to show you main logic. We will have two different lists. This object point list will hold 3D points coordinates, and this image points will save the 2D points, like X and Y coordinates in normal image. And we will use these two point lists for finding parameters with this calibrate camera function here. Now I will explain everything step by step. Let me copy this. Okay, this one. Let me print this. So these are basically, you see, X, Y, and Z coordinates, X, Y, and Z, and there's 48 points because we have like 48 corner points. Let me print the shape as well. Dot shape. Yeah, you see. Now these values will be changed, of course, based on these values. Let me print this again. Yeah, again, there's 48 points, but now you can see, you can think now these values are like index. For example, x and y 0, 0, x1, y0, x2, y0. For example, x1, y0 is here, x2, y0 is here. You can think like this. This is our chessboard. Like each length is 17 millimeter, not meter. And you can think these values as index. For example, this one, x0, y1, x0, y1 is here. And yes, the last step here. Now we will use this square size. Remember that was 17 millimeter. Like length of this one, each is 17 millimeter. We will use this value. You see now this is our real world coordinates. Of course, relative to the chessboard. You can think here as 0, 0, 0. And now relative to this coordinate, this point, these are real world coordinates in meter. I hope this makes sense. If you cannot understand this, you can check OpenCV documentation as well. Let me show you that. OpenCV camera calibration. Yeah, you can read this as well. It's up to you. And not this one, sorry. Yes, this one, you can read this as well. You can see distortions. But anyway, let me continue. So we have basically real world coordinates relative to this point 0, 0. Yeah, you can see exactly same with this one. And now we are reading all the images under this calib images folder. This one, empty images. And again, we are finding corner points. with find chessboard corners function. Again, we are converting our image to grayscale, and we are passing chessboard size as parameter. And if when it found points, it appends object points, like 3D points, to object points list, and it appends 2D points to the image points list. This corner suffix function basically defined the corner locations. Yeah, I saw it in OpenCV documentation. Let me show you that. Yeah, you see. No, not this one. Yeah, you see here. Yeah, you can read the explanation here. Yeah, you see, like, determine their positions more accurately. Function calls corner suffix. And we are saving 2D points to image points list. And you see here 3D points, 2D points, shape of our image. We are passing this tree parameter, and it returns parameters here. And you can save these values to like any file you want. You can save it to txt as well, but I prefer to save it to YAML file. You can see format is clear. You see camera matrix, distortion coefficients, and we have one reprojection error. You see here. So yeah, I think that's it, but let me show you documentation. There was different things, I think. Yes, I want to show you a few things. Yeah, you can see there are different distortion types, like barrel distortion. You can check the math if you want. Yeah, I think that's it. Let me check if I miss anything. Yeah, I think that's it for this video. Thanks for watching. See you soon.